When you walk into a modern building, you expect to be comfortable. You don't want to be too hot or too cold. You want to breathe clean air. For large buildings and factories, this simple need for comfort takes on a whole new level of importance. That's where HVAC comes in. HVAC stands for heating, ventilation, and air conditioning. It's the system that keeps our buildings comfortable and safe no matter what's going on outside. In factories, HVAC isn't just about comfort. It's also about protecting expensive equipment and ensuring the quality of manufactured goods. Think about a factory that makes delicate electronics. Too much humidity could damage the components, while too much dust could interfere with the manufacturing process. HVAC systems help maintain the precise environmental conditions needed for these operations to run smoothly. Without HVAC, our modern world would grind to a halt. Hospitals wouldn't be able to maintain sterile operating rooms. Data centers would overheat, taking down essential computer networks, and factories wouldn't be able to produce the goods we rely on every day. HVAC is the unsung hero of modern life, working behind the scenes to keep us comfortable, safe, and productive. HVAC is all about controlling the climate inside a building. The H stands for heating, which is essential during colder months. Heaters warm the air, making the building comfortable for occupants. The AC stands for air conditioning, which cools the air during warmer months. Air conditioners remove heat and humidity, keeping the building cool and comfortable. But HVAC is more than just temperature control. The V stands for ventilation, and this is a critical aspect of HVAC, especially in industrial settings. Ventilation systems bring in fresh air from outside and expel stale air from inside. This exchange of air is crucial for maintaining good indoor air quality, removing pollutants, and ensuring a healthy and productive work environment. HVAC systems also control humidity levels, which is essential for both human comfort and the protection of equipment and materials. Too much humidity can lead to mold growth and material degradation, while too little humidity can cause discomfort and static electricity. HVAC systems maintain optimal humidity levels, creating a comfortable and safe environment. An HVAC system is made up of several key components that work together to control the indoor climate. Think of it like a team, with each player having a specific role. Heaters are the workhorses of the system during the colder months. They generate heat, which is then distributed throughout the building. Air handlers are like the lungs of the system. They circulate air throughout the building, moving it across heating and cooling elements and through ductwork to reach every room. Chillers are essentially large refrigerators that cool water, which is then used to cool the air. Chillers are essential for air conditioning in large buildings and industrial facilities. Controllers are the brains of the operation. Controllers monitor temperature, humidity, and other factors, then adjust the system accordingly to maintain the desired conditions. These are just some of the main components of an HVAC system. Depending on the size and complexity of the building, there may be additional components such as humidifiers, dehumidifiers, filters, and ventilation fans. All of these components work together to create a comfortable and healthy indoor environment. Understanding how to calculate HVAC needs is crucial for designing efficient systems. Here are some key formulas explained in clear, simple language. Cooling load calculation tells you how much cooling capacity you need to keep a space at a comfortable temperature. It factors in things like the size of the space, the number of people in it, and the heat generated by equipment. Airflow calculation determines how much air needs to be moved to properly cool or heat a space. It's important for sizing ductwork and selecting the right air handler. Power consumption calculation helps you understand how much energy your HVAC system uses, which is crucial for managing energy costs. It involves factors like the wattage of your equipment and the hours of operation. These formulas are the building blocks for designing and operating an efficient HVAC system. By understanding these calculations, you can make informed decisions about equipment selection, system sizing, and energy management. Alright, let's break down those formulas a bit further. So, first up is the cooling load calculation. Think of it like figuring out how much ice you need to keep a cooler cold on a hot day. You have to consider the size of the cooler, how much stuff is in it, and of course how hot it is outside. Next, there's the airflow calculation. Imagine you have a fan blowing on you. The amount of air that fan moves is kind of like the airflow in your HVAC system. You need enough airflow to distribute the cool or warm air evenly throughout the space. And then, there's the power consumption calculation. This one's sort of like calculating your electricity bill. Basically, the more powerful your HVAC equipment is, and the longer you run it, the more energy it consumes. And, well, the higher your energy costs will be. By understanding these concepts, you can really start to see how they relate to real-world HVAC applications. For example, if you add more equipment to a factory floor, you'll increase the cooling load, which may require adjustments to your HVAC system. Let's say you're building a new factory and need to determine the cooling capacity for the HVAC system. You can use a simplified cooling load calculation to get a rough estimate. This involves calculating the square footage of the space, estimating the heat generated by equipment and occupants, and factoring in things like insulation and window size. For example, if your factory floor is 10,000 square feet, and you estimate a cooling load of 20 BTU per square foot, your total cooling load would be 200,000 BTU. This means you would need an HVAC system capable of removing 200,000 BTU of heat per hour to maintain a comfortable temperature. Now, this is just a simplified example, and honestly, actual cooling load calculations are more complex. However, it really illustrates how understanding these formulas can help you make informed decisions about your HVAC system. Factories present some pretty unique challenges for HVAC systems. These spaces are often really large and open with high ceilings and, multiple levels. That can make it tough to distribute air evenly and keep temperatures consistent throughout the building. Plus, industrial processes usually generate a lot of heat, so you need pretty powerful HVAC systems to keep everything in check. Factories might also have specific air quality requirements like controlling dust, fumes, or even humidity levels. Meeting all these challenges definitely requires specialized HVAC equipment and expertise. For example, factories may need large-scale air handlers, high-capacity chillers, and sophisticated control systems to manage the complex demands of industrial environments. The world of HVAC is honestly always evolving, with new technologies popping up to improve efficiency and performance. Smart thermostats, for example, can learn your temperature preferences and adjust the system accordingly, which saves energy and, improves comfort. Building automation systems can actually integrate HVAC controls with other building systems, like lighting and security, to optimize energy use and create a more comfortable and secure environment. And artificial intelligence, or AI, is now being used to analyze data from HVAC systems and spot opportunities for even more efficiency improvements. These technological advancements are really transforming the HVAC industry, making systems smarter, more efficient, and more responsive to the needs of building occupants. Understanding the basics of HVAC is just so essential for anyone involved in the design, operation, or maintenance of buildings, especially those big industrial facilities. By grasping the principles of heating, ventilation, air conditioning, and the key formulas involved, you can make informed decisions that impact energy efficiency, cost savings, and of course, occupant comfort. Remember, a well-designed and maintained HVAC system is honestly an investment that pays off in multiple ways. It ensures a comfortable and healthy environment for occupants, protects valuable equipment and processes, and really contributes to a more sustainable and energy-efficient future. This is really just the tip of the iceberg when it comes to the fascinating world of HVAC. There are, honestly, countless resources out there to help you deepen your understanding and stay up to date on the latest advancements. Consider exploring online courses, industry publications, and professional organizations to further your knowledge. Remember, the more you know about HVAC, the better equipped you'll be to make smart decisions that benefit your building, your budget, and the environment.